So I have joining me today is Dr. Mandy Clement. She is a innovation director at James Cropper Advanced Materials, where she leads the development and commercialization of advanced nonwoven solutions. She has over 25 years of industrial experience. She has a strong track record of translating innovative ideas into high-value, market-ready technologies. She is a chartered scientist, fellow of the Royal Society of Chemistry, and holds a PhD in chemistry. I also have David Tilbrook. He is with a PhD. He's a 26-year tenure at Hexcel. David serves as the Senior Technical Fellow, leading pioneering advances in high-performance carbon fiber composites. He also chairs the Aerospace and Defense Working Group for the European Composites Circular Alliance, which we'll be talking about today, the ECCA. His activities span advanced aerospace materials innovation with a key focus on driving sustainable carbon fiber recycling and circular economy solutions. So with that said, thank you both for joining me on the podcast today.
Great to be here. Thanks, Jonathan.
Thank you, Jonathan.
Absolutely. Before we get into our topic of conversation, Mandy, why don't we start with yourself? Give us a little highlight. I know I've given you given a brief bio on both of you, but I'd love to hear just a little background in your own words of your experience in the industry.
Sure. So as you mentioned, I'm Innovation Director at James Cropper Advanced Materials. I've been with the business since about 2007, so almost 20 years now. And during that time, we've been focused on taking our fundamental technology, which is primarily a non-woven technology, and perhaps we can talk a little bit more about what that is soon, and really helping our customers gain the best value from their products by kind of combining their expertise and combining our expertise and making sure that we're enabling a type of function, we're enabling maybe a fabrication technique, and we do that across the whole composite industry. Really, we have a strong interest in the aerospace defense sectors. We have a strong interest in automotive, mobility. So really across a wide range of areas, and it's really trying to understand unmet needs and trying to iterate and develop our products from there.
David, how about yourself?
Excellent. Yeah, sure. So my name's Dave Tilbrook. I'm Senior Technical Fellow in Hexcel's Corporate Research Laboratory based in Duxford in the UK. Hexcel is a world-leading company in the production of advanced composite materials. We are vertically integrated in producing carbon fiber and then finding ways of enabling aerospace and space and defense companies to use that carbon fiber to lightweight their vehicles. When I first joined the company, I joined in 2000, straight out of a postdoc, and I started working on aerospace adhesives, and I've had about 13 years career in product development in a variety of different roles. And I was lucky enough to be the lead developer on the primary structure material, the primary structure composite, which is used for the Airbus A350XWB.
Mm-hmm.
And then after we'd seen that through commercialization and full application into the aircraft, I started up a new group, a strategic research group in Duxford, looking into, if you like, frontier technologies and developing new enabling capabilities for the business. And one of the things that was my responsibility was tackling the challenge of circularity and sustainability in general on composite materials. And this is really what led us to the activities that we're going to talk about today.
Yeah. So why don't we start with an overview of this collaboration with the ECCA, that is the European Composites Circular Alliance. Maybe you could give us a little background on the alliance first, and then tell us how this collaboration took place.
Sure. You'd like me to do that? Sure.
Yeah.
So the European Circular Composites Alliance is a consortium which has been set up by the European Composite Industry Association, ECCA. ECCA is the voice of the composites industry in the UK, covering all segments. And it was founded by a chap called Jaap van der Voorde and Raphael Plenne. And the ECCA initiative has been very much inspired by the Circular Plastics Alliance. This is the initiative that took place over in Europe over a number of years, which has led to the increase in recycling rates on thermoplastic feedstocks. And they looked at the challenges that various segments within the European industrial base were encountering, with composites not having a series of well-defined ways for recycling, and decided that it was time to take action and start tackling these challenges as an industry. And so they formed ECCA, which has 5 different industrial segments. So one is aerospace and defense, which I'm lucky enough to chair that group. There's a little over 200 members. The other groups include road transportation, marine, and construction. And we have another group that deals with, if you like, common themes that affect all industries equally. We call it the cross-cutting themes group. So it's a collaborative environment in which the aim is to create, if you like, connections between businesses.
Sure.
In order to enable us to develop new circular supply chain relationships.
Yeah, I think you're seeing more of that, right? I mean, the collaboration works best when you have multiple companies working together. Mandy, I want to ask you, so this collaboration centers on some of your technology. We call it the Unimat, which it's enabled by James Cropper's Vectus aligned fiber technology as a model for how recycled carbon fiber materials can achieve the alignment and fiber volume fractions needed to compete in demanding composite applications. Can you highlight the technology before we get into this?
Sure. It's fundamentally, it's a technology that's going to take discontinuous short chop fibers. So the exact format that's available from a carbon fiber recycler, it's going to take that format and it's going to align it. And what that means is we can draw on directional properties from that aligned material. So a bit like, in a way, you can think of it as a discontinuous unidirectional material.
Right.
And we see that format is a really great way to conserve value around carbon fiber. And yeah, I guess you can see there some of the details from our website. We've, just to give a little bit more context about that technology. So fundamentally, we've been working with short chop fibers as a business, as a James Cropper business since 1845. We were actually established. Yeah. So there's a lot of know-how there. We were established as a paper maker, and fundamentally a paper maker is working with understanding short chop fiber, understanding how to form it into, effectively a porous structure that is that can be translated to all sorts of different types of applications. So really, the heart of our technology, there's a couple of stages. The first thing is we've taken that papermaking technology that we've had a couple of centuries to develop, and we've developed a unique wet laid non-woven process. Now, what that process fundamentally did was, or does now, is that will make a random mat. So that focuses on moving fibers so that they're very even. They're evenly distributed around the sheet. And that's been an existing range of products we've been working on for about 40 years. We were established, the part of the business I work in, the advanced materials part, was established with this technology around 40 years ago.
Wow.
Yeah. Now, in that time, over the last probably really about 10 years, we've become very interested in recycled carbon fiber. Again, for that very reason, that it's typically available in the format that suits our process. And a couple of years ago, we began to really challenge ourselves, our team, our innovation team, to say, look, what can we do? How can we add value here? How can we further enable sort of circularity, sustainability through carbon fiber? And we believed the answer to that was to create a new technology that would align the fiber. And so that's what we've developed. We launched that technology at the JAC show this year in March.
Yeah, right.
We've called that technology Vectus, so it's a fiber alignment technology. And the first range of products that we've developed from it is, as you said, is called Unimat. And we believe that's the first of hopefully many ranges of products that we will develop from the Vectus technology. Yeah.
What kind? Excuse me. What kind of response? I'm sure it was. You had a lot of great response at the show.
We did really. I mean, it was quite overwhelming. Yeah, quite overwhelming. We set ourselves a target to launch at JEC, a great place to do that.
Mm-hmm.
And I think as a team, as a Unimat team, we have been quite overwhelmed with the interest and the number of customers who have expressed, have really expressed an emphasis for the need for this type of material. I mean, I think one thing that is maybe a little bit different about our technology compared to perhaps some others is that we have moved the technology into commercial scale. So this is, these are discontinuous aligned materials available at scale. So we've been able to progress that scale up relatively quickly, building on our technology. And the number of people who have approached us to say, there's really a need for these types of materials,
right.
has been, as I say, has been very overwhelming.
From your experience, Mandy, what have been the biggest technical challenges in preserving fiber value during recycling? And I'll follow that up after your answer with a question to David: is the biggest barriers to that in introducing these recycled content into the aerospace market. So we'll start with you, Mandy. What's been the biggest challenges in preserving the fiber value?
Yeah, I think it's getting the balance around the recycling process. So I think you have to choose your recycling process very carefully.
Sure.
And then you have to make sure that during that process you're not overworking your fiber. Ultimately you're going to destroy it effectively. You're going to destroy the strength, you're going to destroy the modulus. But conversely, if your process isn't well suited to your fiber, to the thing that you're going to recycle, you're not going to clean it. That's effectively what we're doing during the recycling process. We're going to take away all the debris, we're going to take away all the remnants of where it's been before, and we're going to produce that nice, clean, ready to use surface. And I think we've probably screened fiber from almost every source available globally, and we've had extremely mixed results. And I think being able to collaborate, as we've talked about here, this whole circularity challenge is not something that we can solve independently. We have to work together. For us, we have to work together with the organizations recycling.
Sure.
We have to be able to communicate what our needs are for the fiber. And I think that's absolutely critical for us to obtain the quality of product in a consistent way. So when I say consistent, I mean, within a batch, I mean batch to batch, so that we can then produce the quality of material that, an organization like Hexcel will find it acceptable. And likewise, we need to be talking, we need to be collaborating to make sure we understand clearly what is needed from our product.
Where are most of your feedstocks right now coming from?
So obviously we are working with Hexcel. to process what we'd call post-industrial waste
Okay.
feedstock. And I would sort of say I think anybody working in this area will appreciate that there's a few different categories of feedstock. And in a way, the easiest, the lowest hanging fruit is that post-industrial waste.
Sure.
Often that's, it's what I would call is reclaimed. So it hasn't moved through the process entirely, but it's fairly plentiful. So we are working with post-industrial waste, all the way through to a fully pyrolyzed composite parts. And I would say typically most of our feedstock is coming via pyrolysis, as opposed to some of the other processes we've considered, things like sulfolysis, fluidized bed methods, the decom process, which is quite a much newer process, relies on high temperature and pressurized steam to clean up those fibers. So yeah, I
Sure.
think we're getting the feedstocks from a range of places.
David, you're the challenge in aerospace. I mean, what I know that they are. I mean, this market is interested in these sustainable materials, but from your viewpoint, what's been the biggest challenge?
So the biggest challenge for finding a route for these particular types of materials into aerospace is really meeting with the requirements for, I mean, quality. In terms of it's a certified industry.
Sure.
So maintaining traceability on feedstock origin, ensuring that we've got appropriate checks and balances to ensure that the material is both in terms of composition and structure is consistent. And that doesn't mean it's perfectly aligned. It just means that it's consistently aligned. That's really the biggest challenge. This is new ground.
Yeah.
These are classes of materials which haven't been qualified into aerospace. We're a way off qualification. Right now, I would say that we are still in the world of needing to figure how to establish the relevant standards, actually, to be able to bring these things in. Close collaboration with James Cropper is enabling us to understand the structural dimensions of them. Ultimately, we would have to have engagements with OEMs,
Sure.
probably even the authorities like EASA or the FAA, to be able to determine what acceptable metrics would be to keep tabs on all of the factors. One thing that the airline industry is very sensitive to is the concept of foreign object debris, which, or FOD is the acronym that they use for that. And this is something that we would have to be very, very careful on as we go through. But
How is that classified? What foreign object debris?
Foreign object debris is usually classified as any material that is not intended to be in the material. So it's intended to capture things like, a piece of tape that finds its way into a laminate, or metal contamination, or whatever. So, but this is not insurmountable. Aspects about the process in terms of how it's cleaned, all of these things are good. The most important thing is to have appropriate standards that capture the consistency of the feedstocks,
Sure.
and also the traceability. Now, we can build up. The interesting thing is people quite often jump straight to the end story about end-of-life aircraft and all this sort of stuff. But actually, fibers originate in, I hesitate to use the waste. I prefer the word, at least before it's a component, I prefer to use the word residual, because it all depends. It's only waste if you choose not to do something with it.
Right.
And so the residuals actually occur in a number of different parts of the manufacturing process. So we produce carbon fiber, and there's residuals from that. There's weaving processes. There's a different type of residual material from that. And even when we weave, there are these lengths of material that are still perfectly straight. They're on bobbins, perfectly, exactly the right quality of material to go into aerospace applications. They're just too short to weave with them anymore. And sometimes we have to divert those to what we refer to as secondary materials. So that's a great starting point. And
Mhm.
then, progressively at different stages, whether it's pre-preg tapes or fabrics, there are ways of capturing those wastes and working them through. And these are the things that we really hope we'll be able to continue to engage with James Cropper on.
So you're saying so residual materials are acceptable, and
Yeah.
so is that what you're saying? We want to classify recycled under residual for this? Or-
Yes, well, they're
Yeah,
recycled, so they can be recycled from the material manufacturing process as well as the component
sure.
manufacturing
Okay.
process.
Yep.
So some of the wastes that we can originate will come from our own businesses.
Mhm.
Um, they're still within the traceability of the aerospace supply chain. So in terms of trying to get something that's a good starting point to finding a way into an aerospace application, it's all about preserving the maximum traceability and the
Sure.
proportional traceability that you can.
What is what is a um how should I say this? What does the approval process on this look like? I know this takes time. So if we were looking ahead with this collaboration 5 years from now, what would success look like moving
Um,
forward?
from Hexcel's perspective,
Yes.
okay. I mean, the first thing I would like to have achieved is that we've found a consistent and mutually beneficial way of us acquiring or recovering the maximum value that we can from residual continuous fibers
Hmm.
by establish and that means not just enabling James Cropper to produce Unimat, but also us having found a way of reincorporating that into a product which could be used somewhere within the aerospace supply chain. It
Yeah.
won't be the original application for which the fiber was intended, but
Sure.
we would like to be able to get to that. That would be a fantastic outcome.
Mandy, for you, what breakthroughs are making a line recycled fiber more viable for structural applications?
Well, I think certainly the recycling processes. I think we've seen over the last, few years, we've seen some step changes in the ability to recover fibre,
Hmm.
to maintain value there, in terms of quality. So that's absolutely critical.
Yeah.
And I think, things like our own Vectus breakthrough, we would consider that a breakthrough in technology.
Yeah.
Um, yeah, being able to align the fibers. Um, so I think a lot of it centers around, yeah, enabling our processes to move forward.
How many of the Vectus machines do you currently have right now in
Well, we
production?
have, yeah, so we have four main machines. And we have also a pilot line. So our main machines are going to make product um, up to about 82 inches.
Hmm.
Currently, we're making the Vectus material up to around, let's call it 1.2 meters wide. And we also have a pilot machine where we can trial out new developments, new materials that we might be a little bit cautious around. We don't want to move into our production environment, and
Sure.
that's around half a meter wide, around 500 millimeters, around 18 inches. At the moment, we are utilizing one of our production machines and our pilot line for our Unimat development work.
It's a very exciting. Last question for both of you because we're running short. I do want to mention, I would love to get both of your perspective on what excites you most about the future of circular composites as we move forward. Mandy, we'll start with you.
I think it's, we've seen advances in this area coming for some time, possibly starting off feeling quite conceptual,
Yeah.
feeling quite futuristic, and now they're becoming real.
Yeah.
We have a commercial material available at scale, ready to go, machine capacity literally waiting. Um, so I think, there's still work to do, of course, as a sector. There's a collaboration. There's still plenty of work to do. But I think the fact that we've made progress, and we're moving towards something that's feels technically and commercially viable is
Right.
pretty exciting.
David, for you?
Oh, for me, it's definitely the possibility of us having materials which are really designed to be recyclable multiple times over, having multiple service lives. The breakthrough that is impactful for us as a composite manufacturer, and we're looking at this from the secondary material perspective, is that James Cropper have got into the aerial weight range, in the region of 100 to 200 GSM,
Right.
that becomes really attractive from a part manufacturing perspective. So this now aligns very well with the weights that are used in conventional unidirectional materials. And if we think this way, the Vectis technology in Unimat provides a mechanism by which we could really think about keeping the carbon moving, and opens up an awful lot of avenues for having composites that can just be used and then recycled, and not relying on having materials that have very long service lives. If you can recycle it well and regain the value, then the range of applications you can
Yeah.
apply sustainable composites and all those benefits really increases massively. It's really exciting.
Yeah. Yeah. And to your point, I was reading, for an aircraft, 30% of the airline operating cost are from the fuel. So weight reduction is a pretty key environment and a huge economic driver, I'm sure, especially right now where the fuel costs are going up tremendously.
Absolutely.
So we're all experiencing that right now. So
Yep. Small differences have very large impacts in
absolutely.
aerospace.
Yeah. Mandy, David, thank you both so much. This has been a great interview. I appreciate your time today on the podcast, and look forward to getting this out to our listeners. I hope you both have a great weekend.
Thank you very much, Jonathan. Have a great weekend.
Yeah. Thank you. Bye now.